When countering low, slow, small drones, it acts like a responsive guard able to lock onto a target within seconds and disable its observation system. How capable is a swarm of unmanned bees? The difficulty of the test continues to increase. The defining feature of fiber optic drones is that they transmit flight data and imagery to the operator in real time through optical fibers. This makes them highly resistant to electronic interference, leaving physical interception as the only effective countermeasure.
发现高速抗干扰自行无人机，距离2公里，光电21，准备拦截。
At this moment, the Lightsaber to 1A enters the scene. It uses a mobile engagement mode, allowing it to maintain suppressive fire while avoiding easy detection by not remaining stationary.
重量目标已锁定，准备打击。
报告，硬杀伤命中，目标击毁。
In terms of strike capability, the Lightsaber to 1A is known for its direct damage approach, generating high energy density over several kilometers to act continuously on a drone's structure, breach its outer shell, and damage internal circuits or power systems. In contrast, the Lightsaber 11 does not rely on destructive force. Instead, it uses pulse lasers to precisely disable key components, instantly blinding the drone and removing its ability to conduct reconnaissance or transmit data. These two modes, soft kill and hard kill, address different ranges and threat levels, complementing each other's operational coverage. And now, the drone swarm has taken off. Our film cruise aircraft has also joined the scene, weaving through the drone swarm to capture tracking footage. This further tests the ability of both systems to distinguish between friendly and potentially hostile targets. The crossing drone carrying offensive equipment is assessed as the highest threat target, while the fiber optic drone specialized in reconnaissance could expose our deployment if not intercepted promptly. The film cruise drone, however, is classified by the system as non-threatening because it carries no weapons or reconnaissance payloads, and its frequency and identification codes clearly indicate a non-combat unit. Based on this analysis, the Lightsaber to 1A automatically activates its laser according to preset algorithms, prioritizing high-threat targets before addressing secondary ones. The first payload-carrying drone has been struck and is falling, followed shortly by the second. Next, the fiber optic drone is hit, and its airframe begins to drop as well. As coordinated partners, both the Lightsaber to 1A and Lightsaber 11 are equipped with phased array radar and infrared reconnaissance systems. They can interconnect through both wired and wireless links, enabling real-time information sharing and precise target identification. As emerging high-tech systems, laser weapons allocate their strike power autonomously through multi-sensor detection and intelligent identification, offering rapid response and strong adaptability to changing battlefield environments. Within a broader operational system, these two platforms complement each other at different ranges, coordinate effectively, and can rapidly integrate with radar, electro-optical, and other early warning systems, forming a closed loop from detection to engagement and enhancing the protection of key areas. Together, these four types of equipment form a layered, three-dimensional air defense network. Among them, shipborne laser weapons stand out for their precision and sustained engagement capability, becoming a new blade of light shaping future naval offense and defense. During the 2025 military parade, one of the shipborne air defense systems mounted on a large extended military vehicle with a circular mirror on top was humorously nicknamed the washing machine by netizens. Yet behind that wide, dark blue mirror lies highly advanced technology. Laser weapons often feature a mirror-like component as part of their optical system. Once a laser beam is emitted, it remains a focused beam over long distances and does not disperse. Additionally, because it travels at the speed of light, it engages a target the moment it is detected faster than even hypersonic projectiles. Furthermore, laser weapons require a high-energy power source to operate effectively. This energy is not meant to explode outward, but to generate heat, specifically extremely high temperatures. Much like focusing sunlight through a magnifying glass, the concentrated beam can reach temperatures high enough to ignite paper. In the same way, a laser uses its high temperature to strike a target, allowing it to damage or penetrate materials on aircraft, small vessels, or other equipment. That is the basic principle behind it. The heat is produced from electrical energy, which requires rapid charging and discharging capabilities. This is why laser systems often include a large unit beneath the main weapon. This component generates and stores the necessary power. The upper section, which directs the beam toward the target, is comparatively small. At the 2025 military parade, a vehicle-mounted laser weapon will also appear as part of a system that includes anti-ballistic artillery and high-power microwave weapons. It can perform both soft kill and hard kill tasks, forming a key part of a three-element counter-drone system. It represents the laser weapon component of this triad. By emitting high-energy beams to disable targets, it operates without explosions, flames, or recoil, and can fire continuously. Another element of the triad is the high-energy microwave weapon. Mounted on an 8A high-mobility chassis, it can disrupt or damage drones and drone swarms across a wide area. At its center is a 6-barrel rotary cannon, with 4 anti-air missile launchers mounted on the sides, giving it a powerful and robust appearance. This forms the third component of the triad, a combined cannon and missile system. It offers rapid response, strong interception firepower, high accuracy, and good mobility. It can operate independently or integrate into a network air defense system using ammunition, artillery, lasers, microwaves, and other methods to achieve both soft kill and hard kill effects. Directed energy weapons are advanced systems that use highly concentrated, directional beams to disable or destroy targets. Currently, they primarily include laser weapons and high-energy microwave weapons. Directed energy systems offer advantages such as rapid response, high accuracy, strong destructive capability, low cost per shot, and large effective ammunition capacity, making them especially effective against low-altitude, slow-moving, small targets, including drone swarms. Tactical directed energy weapons are typically used alongside short-range air defense systems such as rapid-fire anti-aircraft guns and electronic jamming equipment, primarily to counter emerging low-altitude drone threats and protect key facilities and infrastructure. Even before the debris from the intercepted drone has reached the ground, the swarm control algorithm has already activated. A coastal defense shift driven by swarm intelligence is beginning to take shape.
报告指挥长，无人品航线已设置完毕，是否可以出航？请指示。
可以出航。
The L-30 Unmanned Surface Vessel Patrol Formation is now departing the port. Following the route planned by the Zhuhai Public Security Water Command Center, the vessels proceed autonomously toward the mission area. We are accompanying them aboard a traditional marine speedboat. The L-30 patrol vessel is 7.5 meters long, with a top speed of 35 knots and a range exceeding 300 nautical miles. Its streamlined design reduces drag, enabling faster and more stable movement on the water while lowering energy consumption and improving endurance.
前方有障碍物，无人艇保持编队，自主避让。
收到，无人艇进入自主避让模式。
Operating as a formation means that multiple unmanned vessels can dynamically adjust their formation structure based on mission type, vessel status, and surrounding environmental conditions, allowing them to complete navigation tasks collaboratively. Each unmanned vessel has independent sensing and decision-making capabilities, enabling it to break down a mission into smaller tasks and resolve them step by step. The most visible advantage of this swarm intelligence is that when the formation is underway, the command terminal only needs to issue a single instruction, and the vessels autonomously complete formation changes and determine optimal routes in minimal time.
报告指挥长，无人艇编队已到达指定海域，请指示。
立即进入定点值守模式。
收到，已进入定点值守模式，值守半径为300米。
The electro-optical system and radar are continuously rotating, indicating that the vessels have entered active monitoring mode. Bringing the vessel to a stop allows it to perform more precise optical imaging and radar scanning of the target area.
报告指挥长，发现不明船艇进入警戒区域，请指示。
立即识别目标。
收到。
During task allocation and response, the command system rapidly generates an action plan using artificial intelligence. Now, 2 unmanned vessels have approached the intruding ship from different directions, blocking its route and intercepting it, demonstrating strong adaptive formation capabilities.
前方快艇，我们是珠海公安水警，我们是珠海公安水警，
已进入警戒区，请立即离开，请立即离开。
Traditional small unmanned boats have low radar signatures and minimal infrared emissions, giving them natural stealth advantages. This makes them difficult for conventional surface defense systems to detect and intercept. The introduction of unmanned surface vessel systems helps address this challenge. When vessels of similar size encounter each other in narrow waters, unmanned boats can quickly detect and lock onto targets using advanced radar and electro-optical reconnaissance systems. After receiving a command, the unmanned vessel formation can autonomously organize its units through the swarm control system to outflank and encircle a target, and if necessary, disable it through direct impact. We are currently positioned alongside the first echelon. UAVs and unmanned surface vessels are steadily moving toward deeper operational integration. The goal is for fleets of unmanned boats, drones, and unmanned submarines to form an interconnected operational grid. Wherever our maritime interests extend, this unmanned grid will be deployed accordingly. The aerial swarm sweeps across the sea surface, while the blade of light cuts through the waves. On future battlefields shaped by data and algorithms, unmanned systems are gathering momentum. In quiet moments, the scale of this transformation becomes clear.